All right, we're at the 2-3 video here. AF, autofocus. That's funny. I like that. All right, so we have two big goals here. The second, rationalizing complex denominators, requires us to use complex conjugates. So let's start off. A complex conjugate. So a complex conjugate, if a complex number is a plus bi, then the conjugate is a minus bi. Now let's pay attention here. The a is positive in both of them. The only thing that switches is the sign of the imaginary part. Okay? So here I have a plus bi, the conjugate a minus bi. So let's do a few examples of this. All right, the first example, let's do 1 plus 3i. Okay? The complex conjugate for 1 plus 3i is simply 1 minus 3i. I cannot stress this enough. It is not negative 1 minus 3i. That is a gigantic no-no. And I'm going to see a lot of people who refuse to watch the videos. They're going to put the negative 1 there because they think they know what they're doing. It is so important to watch these videos. Extremely important, especially when it comes to little things like that. All right, let's do another one. What if I have 7 minus I? All right, so here's a complex number, 7 minus I. Well, the complex conjugate for 7 minus I is going to be 7 plus I. Easy enough. Now, what happens like if I have negative 4 plus 2i? What's the complex conjugate then? Well, there's negative 4 plus 2i, then the complex conjugate, I do nothing with the real part. The real part stays the same, always. And then we say the imaginary parts change signs. So it went from a negative 4 plus 2i, the complex conjugate would be negative 4 minus 2i. And here's what's really interesting. The reason why we use this is that there's a really nice property here. What happens if I multiply a plus bi times a minus bi? Here's something that's extremely fascinating. So, what happens? I want to investigate what happens whenever I multiply complex conjugates. Here I'm multiplying every complex conjugate ever, which I think is really neat to do. So a times a gives us a squared. A times negative bi is a negative a bi. Bi times a is a positive a bi. And then positive bi times a negative bi is a negative b squared I squared. Now remember I squared is negative 1. So I'm going to replace that and combine like terms. So a squared is a squared. A negative abi and a positive abi, that goes to 0. And then I'm left with negative b squared times negative 1. So now one more cleanup here. I get a squared and negative b squared times a negative 1 is a positive b squared. Whoa. This is important to note. There is no imaginary part anymore. Imaginary part. Whoa. Whoa. That's crazy. Okay, now let's rationalize complex denominators. So the second half, the big main goal of what we're dealing with here, what we're going to deal with here is rationalize complex denominators. I don't remember what that letter is. Well, who cares? It's math. It's not English, right? So we're going to rationalize a complex denominator. What this simply means is we're going to turn it from a complex number, the denominator of a fraction, the denominator of a fraction, we're going to turn it from a complex number into a number that we could put on a number line. So it's going to go from something that's complex into something we could put on a number line, like a real number that doesn't have any imaginary parts. All right, so the process is quite simple. We're going to multiply the numerator and denominator by the conjugate of the denominator. It's a lot harder to say than it is to do. It's one of those things in math. It's much more difficult to say it than it is to do it. Hi, Kate. How are you, babe?
Good. How are you?
I'm doing good. Enjoy your walk.
Thank you.
My wife and child are going on a walk. All right, so let's try an example. So if I have 2 plus 3i over 1 plus 4i. Okay? Nice and simple here. What I need to do is I want to take the denominator here. Currently, the denominator is a complex number. And I want to turn it into a number I can put on the number line. Okay? So, I want to multiply the numerator and the denominator by the complex conjugate of the denominator. All right, so here we go. The complex conjugate of the denominator is going to be 1 minus 4i. So 1 minus 4i. 1 minus 4i. Now, note, this 1 minus 4i divided by 1 minus 4i, that is just simply 1. So I'm not changing the value of this number in any way, shape, or form. I'm just multiplying it by 1. It's an extremely fancy 1, but I'm only multiplying it by 1. I am not changing the value in any way, shape, or form. Okay, so here I like to go ahead and put my fraction bar together because I have to multiply 2 complex conjugates at the same time. 2 complex numbers right at the top and then another one at the bottom. So this is going to go fairly quickly, so if you need to pause as we go, go ahead. So 2 times 1 is 2. 2 times negative 4i is negative 8i. 3i times 1 is a positive 3i. 3i times negative 4i is a negative 12i squared. Now the denominator. 1 times 1 is 1. 1 times negative 4i is a negative 4i. 4i times 1 is a positive 4i. And then 4i times a negative 4i is a negative 16i squared. Now the two things I want to do on this step, combine the middle terms and switch the I squareds to negative 1. So I'm going to go ahead and put my fraction bar in. And 2 stays as 2. A negative 8i plus 3i is a negative 5i. A negative 12 times negative 1. And now for my denominator. 1. And then negative 4i plus 4i goes to 0. And then I have negative 16 times negative 1. And now I could clean this up just a little bit here. And I'm left with 2 minus 5i plus 12 over 1 plus 16. And then finally, one more step to clean this up. I would be left with 2 plus 12 to get me 14 minus 5i over 1 plus 16 is 17. Now, in some other classes with some other teachers or however else, you may also see this rewritten as 14 over 17 minus 5 over 17i. And that's okay because I have a monomial in the denominator. And this is fine to do it that way. Let's do one more. And then I'm just going to give a real brief example on another one that you might find a little bit tricky. So let's do one more quick example. what if I have 3, let's try 1 plus 3i divided by, and let's go with 4i. What's the conjugate of 4i? Well, the conjugate of 4i would be negative 4i. Here I'm going to put negative 4i here as well. So then I can multiply the numerator. So I'm going to distribute backwards here. So negative 4i times 1 is a negative 4i. Negative 4i times a positive 3i would be a negative 12i squared. And then 4i times a negative 4i is a negative 16i squared. And then we could simplify this. I'd left with a negative 4i minus 12 times negative 1 over negative 16 times negative 1. So negative 12 and negative 1 is a positive 12 minus 4i all over, and negative 16 times negative 1 is a positive 16. Now, the big 3 here, 12, 4, and 16, they all reduce by 4. So I could simplify this and have it 3 minus I all over 4. You may also see this rewritten as 3/4 minus 1/4 I. But here, this is where Mr. Stevens likes to leave it. All right, so we've seen how to do a complex conjugate when you have a monomial in the denominator. We've seen how to rationalize when you have a binomial complex conjugate, right? So you should be good to go through the 2-3 homework.